Yeah. So I'm going to be introducing the first method here, interrupted time series. I'm going to look at a little bit how it could be used, when it could be used, and a little example of when I've used it in my own research. So what is an interrupted time series? As you can see, clues in the name. It's almost a complicated name, but not quite. If you imagine your outcome is being plotted across time, an interrupted time series is looking at what's the trend before you put an intervention into place and the trend after you put an intervention in place. And you can see there, this hypothetical intervention, the pre-period is saying as a slowed linear increase in this unnamed outcome, and the intervention has been tested to see if that can produce a difference in the outcomes. And from here, it looks quite clear that the intervention at time 2 has created a jump up in what this outcome is. And that's so that's a key thing. It's a time series going along a time axis, and it's interrupted by breaking that linear model at the point of intervention and testing whether that is a significant effect. We'll run through the steps of how you'd put together an interrupted time series analysis before showing you a worked example. The first step, of course, clearly is having an intervention to test. And you want to define that as an exposure, an event that splits a pre-period into an unexposed period and a post-period after. So here's an event picked, again, as an example. The plastic bag charges were introduced. I think that's the Scotland date, or is it England date? I can't remember. I looked up one to be more relevant, but you would expect that what's happening before that date and what's happening after that date would be split into two very well-defined unexposed and exposed periods. So that's kind of the key first part, and those are your comparator periods. Secondly, you'd want to look at a measurement of the outcome. This is unrelated to the last one, just in case you think plastic bags were causing or preventing the flu. But for example, you might be looking at the flu rates in a given year as your outcome, and you'd want to collect it for each of these years. Now, the key thing about an interrupted time series is it needs to be measured at regular time points, one measurement for each time slot. And we want to be looking for periods before and after the intervention to first of all fit a baseline trend, and then to see if you can detect a post-intervention trend. Outcomes such as counts or continuous variables suit this method best for looking at plotting that linear model before and after. The other key thing is a good strong interrupted time series will be looking for an outcome that is immediately affected and therefore detectable at a defined time point. If your outcome, for example, is cancer incidence, that might be years and years and years after an intervention such as smoking bans. So defining an intervention cutoff period would be very difficult and very hard to detect. So you might need to think of another outcome there. Ideally, as in all research, you'd want your outcome to be as close to the aim of the intervention as possible, but obviously there's restrictions there, and maybe you want to look at rates of cigarette sales or something like that as a more immediately affected potential outcome. Next step is to choose an impact model, which is just a fancy way of saying, what do you think the intervention will do when you roll it out? Each of these dotted lines is an intervention being rolled out, and these are a set of imaginary potential ways you would define an intervention of having effect. So it might be simple as just we'll call it a level change, where things jump up but there's no change in gradient. That's A. Or a trend change, which is B, where there's no immediate jump but the trend of the line changes, or both in model C, or a variety of other potentially more complex ways that the intervention might be expected. This is something you want to think about and choose before you run your models, because this all defines how your model will look when you put it together. And then finally, we get to the real juice of it. You would then have your outcome data and your regular time point measurements, and you'd fit a linear model. This maybe looks like the most complicated part, but with the kind of the stats background and knowing how to fit linear models, this will produce two coefficients, which are the estimates of your outcome. I've underlined there First one would be looking at what the level change would be, the initial jump up, and the second one tells you what the trend change is. So these are the things you're quantifying to see, you can always leave out one or the other if you think it will be one of the other impact models, but did the intervention at time point T create a difference in level or trend at that time, indicating an effect? The other thing that might be useful to add in is think about, would a control help in this case? And how do you fit a control to an intervention, interrupted time series? Well, the control is used to predict what a level trend change would be in the absence of your intervention, which might be necessary. I'll show a little bit of that in the worked example. But in effect, you would then, in model B there, you're applying the changes that were seen in the unexposed time series to the exposed one. And that is the null effect, in a way, if it would have seen the same things. That's a bit complicated, but we'll work through it and we'll see. So there's a kind of steps to putting together an interrupted time series model. I'll give you one example, and then we can maybe think about questions of when you might use it, how you might use it. My example that I used in my research was the teenage pregnancy strategy, which is an England-based intervention to reduce teenage pregnancies. And the strategy was a 10-year strategy launched in 1999 with the goal of reducing under 18 pregnancies by 50% in 10 years. A very ambitious goal that they set out. When they did an observational check in 2014, they found that actually there was a 51% reduction. It's a little bit late, but actually seems to be good and seems to be keep on going. And if you check the ONS stats every year release, it does seem to keep reducing. So something seems to have gone right, which is good. This was, you can see in the media, this was hailed as a success, one of the most successful health interventions ever. But how much of that would have happened anyway? How much of that would have happened even in the absence of the strategy? Was there a trend in going down that would have continued? So can we use interrupted time series to get a better picture of the strategy's impact? For this, though, I used a controlled interrupted time series and using Scotland and Wales as a control. So this can hopefully show us what trend and level changes England would have seen even in the absence of the strategy. This allows control for both background trends and either increasing or decreasing baseline, but also control for common events that are not related to the strategy that may have been full UK exposures. For this outcome, we're going to be looking at under 18 pregnancy rates from 1992 to 2016. First, we'll do an England-only interrupted time series model. You can see that the points there are the observed pregnancy rates across the years, and the solid red lines are the best fit linear regressions for the pre and post period. The dashed yellow line is the prediction as if the pre-strategy trend had continued on into the post-strategy years. And this seems to be giving quite a large estimate of effect. That change in trend, minus 2.22, is the difference between the positive trend and the negative trend in the strategy period. Now, I'm going to tweak this model slightly because you'll see in the pre-strategy period, there's 3 dots here which have jumped up really high. That's hypothesized to be scares about whether the combined oral contraceptive pill might have negative effects. It was published in 1996 and was associated with jumps up in pregnancies across the board. So we can maybe put a wee corrector in there for allow the model to fit that jump. But again, we still see a change in trend that's associated with the launch of the strategy there. So that, again, still looks like the strategy was effective. But we can add in Scotland and Wales data. When we then compare it with Scotland, first of all, you'll see, so this is quite hard to see because the grey dots there are Scotland rates observed and the red dots are the England rates. And the yellow dashed line now is what would have happened if England had seen the same level and trend change as Scotland had at that period. So Scotland had no strategy and saw a rapid decrease in pregnancy rates. England had a strategy and sees pretty much the same decrease in pregnancy rates. The difference in trend is very, very little here. Comparing to Wales then, again, we can use Wales observations. And again, Wales sees almost exactly the same downward trend post-strategy as England saw. So both of these control models are being used to see what would have happened as a UK-wide event not related to the strategy And it appears in both cases that the strategy didn't contribute any extra decrease in pregnancy rates across this period. So looking overall, what does this analysis add to our understanding? Well, we did see that England saw a reduction in teenage pregnancy rates during the strategy period, and this does seem contrary to previous trends, either a stable or maybe slightly increasing trend, depending on whether you correct for those initial that initial pill scare, as it's called. Now, does that mean the strategy caused that reduction? Well, given that Scotland and Wales trends indicate that there was a wider cause of the same magnitude as seen in England, this does seem to indicate that the strategy was not adding anything to what would have happened anyway in the counterfactual England that didn't do this. The interrupted time series analysis here is accounted for both baseline trends and non-strategy trends, non-strategy related changes. Is interrupted time series analysis a good tool for this analysis, or for your analysis? We can think that through as we apply it to other circumstances and things we want to measure. Well, the interrupted time series analysis works great for controlling for baseline trends. As we see, if things are going up, you'd expect them to keep going up. So an increase is not exactly evidence of effect. And it can control for independent effects if you have the control series. I've compared across countries here, but you can also use outcomes in the same population which aren't affected potentially by the outcome. But a few things to watch out for. In this analysis, were the comparators truly unexposed? That could be a critique of using Scotland and Wales, in that some of the strategies output was a nationwide media output that may have impacted Scotland and Wales as well, or potentially that they had simultaneous interventions causing exactly the same trend changes at the same time. So you want to query that with your comparators. Another thing to watch out for is seasonal data may need more complex handling. We're going to maybe chat about some methods of that later on. That's quite a complex and interesting area as well. That's to wrap up there. That's kind of interrupted time series brief introduction. I think I've hit the 12 minutes exactly. Was I good on there? So I think I'll pass back to Christine, who will